Alright, Surveyor Sam has a measuring tape that's normally 100 feet long. But it expands in the sun, and on a particular hot summer day, the tape expands by 0.2 feet. Okay? So on that day, Sam's tape indicates the distance between 2 points is 675 feet. But Surveyor Sasha has a special tape measure, and she goes out and measures that same distance and gets the actual measurement between those 2 points. And the question is, what is the length in feet that Sasha reads? Okay, so we're trying to find the actual distance between those 2 points. So let's take a look at what we got here and kind of think it through. So we have a tape measure. It's normally 100 feet long, but it lengthens in the heat to be 100.2 feet long, essentially. So that means if I knew an actual distance between 2 points of 100 feet, and I laid this stretched tape measure down beside that 100-foot measure. Maybe it's Sasha's tape measure. Maybe they're laying them out side by side. Sasha's is actually 100 feet. Surveyor Sam's is stretched. So he's going to measure her tape measure, the actual 100 feet, as being something less than 100 feet, right? Because you can imagine his tape measure is longer, and so that 100-foot mark is out there farther, out beyond the actual 100-foot mark on Sasha's tape. And so whatever he measures is going to end up being less than what the actual measure is. So the actual measurement is more than what Sam's tape measure says. So that's a good idea, because that's a good thing to know, because if we get an answer that's less than 675 feet, we know there's something wrong, because Surveyor Sam is going to measure something less. So the actual distance is going to be more than what Sam is going to measure, because his tape measure is too long and it's stretched out. Okay, make sense? So all right, let's write down what we know. So we know that if we were to go out and lay out this tape measure and measure something that was actually 100.2 feet, Sam would measure. He would measure 100 feet. Okay, and so he's measuring for every 100 feet. He's measuring, his tape measure is too long. So all of the distances would be proportional to this ratio. So if we want to know the actual measure between the 2 points, where he measured 675, we just need to solve this ratio. So let's do that. If we multiply both sides by 675, we get x by itself. So x is equal to 675 times 100.2 over 100. Okay? So let's see. Let's get rid of this decimal. I'm going to multiply both top and bottom by 10. That'll help me, I think. Then I'll get 675 times 1002 over 1000. Now I'm dealing with integers. And really the arithmetic is the tough part of this problem, because I told you couldn't use a calculator. If you have a calculator, you can easily plug those numbers in and figure it out. But let's break down these numbers. If you're not given a calculator, probably the best thing to do would be to factor these numbers and see if you can get common factors between top and bottom, and then you can simplify the arithmetic. So this ends up being 5 times 135, and 135 ends up being 5 times 27, which is 3 times, oops, that should be a 3, 3 times 3 times 3. Alright. Now, 102, I know that's divisible by 3, okay? So, that's 3 times 334, okay? And I know it's divisible by 3 because the digit sum adds up to 3, and it's divisible by 3. Now, this is even, So let's break this down further. So that's 2 times 167. And 167, I'm not going to bother with that. Let's go down here. I know that 100 is 4 times 25, so that's 2 times 2 times 5 times 5. Okay. Oops, that should be 1,000 because I multiplied it by 10 over 10. So that should be 1,000. Okay, so we need another 2 and another 5, right? All right, let's find common terms. Okay, I see 2 5s up here, and I see 2 5s down here I can get rid of. Let's see, I got these 3s up here. I have a 2 here and a 2 here. And that's all the common terms. So what am I left with? Let me write that down. I have 3 times 3 times 3 times 3. Okay, so I got 1, 2, 3, 4 3s, and then I've got 167. And then I have on the bottom, I have 2 times 2 times 5. Alright, so let's figure that out. Now, this is 9 times 9, so we have 3 times 3 times 3 times 3, so that's 9 times 9, which is 81. So let's take 167 times 81, okay? And we're going to get 167, and then 2 times 8, that's 56, 48, 53, and so we have 13. Okay, so it's going to end up being 7, 2, 5, 3, 1. Okay, 13,527. And on the bottom, that's 4 times 5, which is 20. So let's divide 20 into 13,527. Okay, so if I take that times 6, I get 120. Have 15 left over, drop the 2. I can take it times 7, that gives me 140. Have 12 left over, drop the 7. There's 6, 120. I have 7 left over. And let's see, I gotta put a decimal in here. If I take that times, I can just drop a 0 at this point. If I take that times 3, I'm gonna get 60. Let me scroll down, just give myself some more room here. 60, 10 left over, and drop a 0, and 5. Right, so 5 times 20 will give me the 100. Alright, so there's our answer. After all that arithmetic. Like I said, if it's arithmetic, that's the tough part. So the actual measure of the distance that Sam measured as 675 is actually 676.35. And that makes sense because the actual measure is longer than what Sam measured, right? We expect that because his tape measure is too long, so it's been stretched. So if he were to measure 100 feet, he would measure something shorter than 100 feet because his tape measure is sticking out too far beyond the actual 100 feet. Okay? So it makes sense. So there we go. Answer is 676.35 feet.